tutorial, I will be showing you how you can find the best solution for an optimal transportation problem. And I will be showing you how you can find the solution using the Python module Pulp. Let's imagine that you own the Walmart company. You have many warehouses and many stores across the country. For this video, say we have 3 warehouses and 3 stores across the country. Thanksgiving Day is coming, and in your warehouses, the first warehouse has 30 truckloads of turkeys, the second warehouse has 20, and the third warehouse supplied 50 truckloads. In history, when Thanksgiving Day is soon coming, it is known that Store 1 can sell up to 30 truckloads of turkeys. Store 2 can sell 30 truckloads, and Store 3 can sell 40 truckloads. When Thanksgiving Day passes, they won't be able to sell so much. Because they want to get them to the stores before Thanksgiving, we want to get all the turkeys from our warehouses to the stores. The cost for delivering 1 truckload of turkeys from warehouse 1 to store 1 is $5,000. The cost for delivering a truckload of turkeys from warehouse 1 to store 2 is $1,000. So that means that store 1 and warehouse 1 are more farther apart than warehouse 1 and store 2. And the cost comes from like the gas, the labor, and stuff. How can we find the minimum amount of transportation fee? How much turkeys should each warehouse deliver to each store to minimize the cost of transportation? First, we see this situation here is like this, only that we use variables here. In these small squares is the total amount that we should transport from the warehouse to the stores. Here we have the cost per truckload. The total cost of transferring all the turkeys from the warehouses to the stores is the amount of truckloads times the cost per truckload. We here plus them all together. As you can see, this is an linear equation. A linear equation is when all the x's are just to the have exponent of 1. You can see here. Here we have this linear equation where we just have x. Here, this one is not linear. So if we have, you see like the squares or square roots or cosines or sines, as long as it's not simply x, then it is not linear. When we have a linear equation, we will get corners when we graph it. If it's not linear, we will get these continuous lines. With these corners, we can easily find the minimum point. Over here we have these 4 points. If we want to find the minimum here, we have to find right at the bottom. Now, since this is linear, we can first randomly find a point, and then we slowly adjust until we find the lowest point. So whatever number we put in, we will get a point. Let's first say from warehouse 1, we transport all the turkeys to store 1. Now, store 1 has enough turkeys, and warehouse 1 ran out, so we cross these out. From warehouse 2, we transfer all the turkeys we can to store 2. Here, we have no more turkeys at warehouse 2. And warehouse 3, we transport all the turkeys we can to store 2, which is 10, since here we already have 20. And then we transport the rest to store 3. Here we have a point. We find the total cost, so this times this, plus this times this, plus this times this, plus this times this. The total cost is $340,000. We have 1 point now. We want to see if we can find a smaller point. To do that, we can see here that we transported turkeys over here and over here. Over here we have a cheaper price of transporting turkeys from warehouse 1 to the stores. So if we want to transport turkeys here instead, we have to remove some of the turkeys we transport here. Before we do that, we also see that if we remove some turkeys we transport here, we have to transport more turkeys to store 1 somewhere else. So we transport them here, and if we transport more turkeys here, we have to transport less turkeys here. Before we do that, let's first see if it's worth it. You can see that this will be minus x, this will be minus x, here will be plus x, here will be plus x. 5 times minus x equals to negative 5x. Here will be minus 3x. We will minus 8x, and here we will minus 4x. Here we will plus 4x. So we see it's worth it. The cost will remove more than we will put back on. So here, we want to find the maximum possible value of x to minimize the cost. And we see it's 20. Since if x equals to 30, this will be negative, and we can't have that. We have x equals to 20. Then we find the total cost so far. So far we get another point, and it's 260. Let's see if we can find another point where we can adjust. Over here, at warehouse 3, we see that transporting turkeys to store 2 is cheaper than store 3. Before we adjust, we want to see if over here, you see that if we want to add x here, we have to subtract x somewhere else. So the only place we can subtract x is here. Then here will be add x. We see that 1 plus 3 is greater or smaller than 1 plus 2, and it's greater. So since we remove more x than we put back in, we will save money. So over here, we find the maximum possible value for x is 20. Here we get this. We find the cost so far. It's $240. Let's see if we can make it. We can get a cheaper value. We see if we want to, let's see, in warehouse 1, we can see that transporting to store 2 is cheaper than store 3. So we see if we can adjust anything. Wait, let me see. We see if we can remove some from here and put them here. If we want to remove some here, we have to add it somewhere else. We cannot add it here because that we will have to subtract here. We can only choose to add some here and then subtract it here. Let's see if it's worth it. Here 5 plus 1, so we subtract 6x, but we have to add 7x, so that will not do us any good. And how about we removing some here and adding them here? We see that if we remove some here, we should add it somewhere else. We cannot add it here because there is no place for us to subtract here, so we add it here. 2 plus 1 is smaller than 1 plus 3, so it will not do us any good either. In warehouse 2, we already transported to the cheapest one we can. Warehouse 3, we also transported to the cheapest we can. This is our final result. Now, our table previously is something like this. Here instead, the rows are labeled with U's and the columns are labeled with V's. So that's what the computers or Python will use. First, we have our cost here, and we have all these costs. First, we set U1 equals to 0, since that would be the simplest form. C11 equals to row 1 plus V1. We want to find V1, so we can get that V1 actually just equals to this. Now, with that, we can find V2, and then U2, then we can find V3 and U3. With the values of the V's and U's, we can identify whether or not some other places need adjustment. So, in real life, we can have many V's, like hundreds, and so are the U's. We simply input all the information into our Python program. They will find the values of U's and V's and adjust everything that needs to be adjusted until the cost is minimized. Now let's have a look at our Python program. From Pulp module, I import all the packages and functions. Here I have a list of my warehouses, the list of my stores. Here I have a dictionary of the maximum amount we can ship to store 1, store 2, and store 3. Here's the supplies of the warehouses. Here I have the cost for shipping turkeys from the warehouses to the stores. Here I define a variable problem and I assign an LP problem to it, and I simply name it cost. And our problem will be to minimize the cost. Here I have routes. I will have a list of all the possible routes from warehouses to stores. Now, in amount, I will assign LP variable. Let's have a look at what it is. Here I have LP variable. This class models an LP variable with the specified associated parameters. So parameter name, and here you see all this. Now, I have a dictionary of my shipment, the amount I ship, the warehouses and stores. I want to add the sum of the expressions in these brackets. So LP sum will return, over here, will calculate the sum of a list of linear expressions. Now, for every store in stores, I will add the sum of the linear expressions in here, and they should be smaller or equal to the maximum amount we can ship. And here, now I will solve our LP problem. I print the status of the problem. LP status will return the status of what we pass in these brackets. For every variable in problem.variables, so an LP problem.variables will return, you can see here, a list of problem variables. So for every variable in there, if the value of that variable is greater than 0, we print the name of the variable equals the value of the variable. Here I print the total cost is the value of the objective of our LP problem. Let me run this. Here they give us the minimum cost for transferring our turkeys. Now, let me switch up the numbers a bit. Let's say it's more sophisticated. Now, in real life, we can have hundreds or thousands of stores and warehouses, and with this program, we can easily find the minimum cost for transporting the turkeys or other products. And there is also thousands of different products that we want to transport. Here they give us the minimum cost of transporting all the turkeys to all the stores. If you have any questions, requests, suggestions, or comments, please leave them down in the comment section below. Please subscribe to my channel. It's called NetsEDU. Please hit the thumbs up button if you enjoyed this video. Today is February 7th, 2020. Thank you for watching and have a nice day.